H- Hello students. So today we are going to study about alkanes. Now what is alkanes? Let us see. Alkanes are aliphatic saturated hydrocarbons containing carbon-carbon and carbon-hydrogen single covalent bond. Now what is saturated hydrocarbon? The hydrocarbon which is having a single that is covalent bond, that is carbon carbon or carbon hydrogen single covalent bond. They are not having double bond or triple bond. So and aliphatics are those hydrocarbon which are having open chain or maybe closed chain compound, but they are not aromatic compound. Now what is alkane's general formula? Alkane's general formula is CnH2n plus 2. Now, what is N? N, it stands for the number of carbon atom in the alkanes. How many numbers of carbon is present? It depends, that is, it denoted by N. So it stands for the number of carbon atoms in the alkane. Now, next slide. Now, isomerism in alkanes. Now, isomers are organic compound which is having same chemical formula but a different structural formula. So hydrocarbon with the same molecular formula but different structural formula are called as isomers. Now, what is isomer? Now let us see, they are having the same molecular formula. If you see butane and 2-methyl propane, they are having the same molecular formula, that is C4H10. In butane only, that is 4 carbon is present and 10 hydrogen atom is present. Whereas in 2-methyl propane, 4 carbon is present and 10 hydrogen is present. So they are having the same molecular formula but different arrangement of atoms. Next, so alkanes with more than 3 carbon atoms, they generally exhibit structural isomerism, and the phenomenon is known as that, in particular the chain isomerism. So in organic chemistry, we come across some compound which is having the similar number of atom, but they are having different physical and chemical properties, and they are called as isomers. So butane and 2-methyl propane, that is N-butane, this is the chain arrangement of carbon atom, whereas this is the branch arrangement. So N-butane and isobutane, they are the isomer of each other, and the phenomenon is known as isomerism. Again, I repeat, isomer, they are having the same molecular formula, but they are having the different arrangement of atoms within the molecule. So they are having, that is C4H10, same molecular formula, but the arrangement of atom is different. In N-butane, the chain structure, that is chain arrangement of carbon atom is present, whereas in isobutane, it is a branch arrangement, that is 2-methyl propane. As I repeat, the alkanes, that is having more than 3 carbon atom, they exhibit isomerism. So if you see alkanes and isomer number, alkane, in methane only 1 carbon is present, in ethane 2 carbon, in propane 3 carbon is present, in butane, pentane, hexane, that is the number of carbon increases. So more than 3 carbon atom, it exhibit isomerism. As we studied about the butane has 2 isomerism, that is 2 isomer, that is N-butane and isobutane. So now let us study about pentane. Pentane, that is carbon number of carbon is C5, that is 5 carbon and H12. Now this carbon, it is having 5 carbon. It can be arranged in the three structure arrangement of, that is the atoms can be arranged in the three form. For example, pentane, that is N-pentane. This is the chain structure, that is the arrangement. It is done in a chain form. Whereas in isopentane, in this it is a branch chain, that is 2-methyl butane. If you see pentane and isopentane, that is 2-methyl butane, it is having the same number of carbon atom and the hydrogen atom, that is 12 hydrogen and the 5 carbon atom. So both are having the same molecular, that is same molecular formula, but the arrangement of atom is different. That is, this is the chain, whereas this is one is branch one. Another can be another isomer is, that is 2,2-dimethyl propane, that is neopentane. If you see, this is also having the same number of carbon atom and the same number of hydrogen atom, that is neopentane. So in this pentane, it is having the 3 isomer, that is the number of carbon and hydrogen can be arranged in 3 form: a pentane, 2-methyl butane and 2,2-dimethyl propane. Whereas hexane, it is having the 3, that is it is having 5 isomers and the number of carbon is 6. Now let us study about conformations and torsional strain. Now conformations and torsional strain. Conformation in this different arrangement of atoms can be converted into one another by rotation about single bond. They are called as conformations. It means the atoms can be converted into one another by rotating the single bond. So these type of arrangement can be done by just rotating about single bond. It's called as conformation. Now there are types of the conformations: eclipsed conformation, staggered conformation, skew conformation, the infinity of intermediate conformation. In this eclipse conformation, the arrangement of atoms or the group of atom in the molecule, it is resulting in a 0 degree, that is dihedral angle, and it is having a maximum potential energy, that is maximum strain. Eclipse, it is having maximum strain and the stability is low, whereas staggered, in this it is a low strain structure and the stability is high. Or you can say it is a eclipse, it is having a high energy conformation, whereas staggered, it is having a low energy conformation. For example, let us take the example of ethane molecule. They are having eclipsed conformation. Now in this eclipsed conformation, if you see this hydrogen and this hydrogen, this one is carbon and this is one is carbon. Now this hydrogen and this hydrogen, they are in the same plane and they are parallel to each other. So they are having a eclipsed conformation, that is they are having a high strain. This hydrogen and this one hydrogen, they are having the high strain. The bond strength should be same for all this, but the molecule is not restricted to any of them and it can freely change from one another to another. Now in this hydrogen and this hydrogen as well as this hydrogen, they are in the same plane and they are having the strain. Now in next, this is the eclipsed conformation. So to release the strain, the bond can be rotated. Now the bond can be rotated, that is it can be changed from one another, involve rotation about the carbon-carbon bond, as there is a free rotation about the carbon-carbon single bond. Now, if you see in this staggered conformation, the hydrogen, that is the hydrogen, to release the strain, this hydrogen can be rotated. I can rotate this hydrogen in the next plane. Now the, and whereas in this, that is the, this hydrogen and this hydrogen, they are also in the same plane. So there is a high strain. Now to release the strain, I have rotated this hydrogen as well as this one. So now they are in a different plane, and they have moved away from each other. So they have moved away from each other, so now they are stable. So these conformation are known as staggered conformation. Staggered conformation, in this, they are having more stability and less strain, whereas eclipsed conformation, if you see, the bond are the, this hydrogen and this hydrogen, they are very close to each other and they are having high strain. But in this staggered, they are very far from each other, so they are having very less strain. So these are known as staggered conformation. Whereas eclipse, in this two hydrogen as well as this third one, they are very close to each other. So they are very close to each other, so they are having high strain. So to release the strain, I can rotate this bond in the next plane. Whereas even to release this bond and to release this strain and as well as this third strain, I can release the strain by rotating the bond. So I can change from one to another involving, that is, rotation about the carbon-carbon bond, as there is a free rotation about the carbon-carbon single bond. For example, conformation of ethane. Now there are representation of ethane can be done, that is wedge and dash structure, sawhorse and the Newman. Now in the Newman projection, it is the staggered. As you can see, these two hydrogen and they are very away from each other, so they are having less strain. Whereas in this sawhorse, that is Newman eclipse one, these two hydrogen, they are very close to each other, so they are having very high strain, so they are having less stability. Whereas in Newman, they are having, they are far from each other, so they are having more stability. Now this is the rotational conformation of ethane. If you see, this hydrogen and this hydrogen, they are having 0 degree. That is, this is the degree, that is, it is the dihedral angle. It is the dihedral angle between the two adjacent atom. It is 0 degree. Now to release this strain, that is, it means the two hydrogen, they are very much close to each other, therefore they are having angle 0 degree. So now this hydrogen can, I can turn, that is, I can rotate it to release the strain. Now the angle is 60 degree. So they are having a 60 degree dihedral angle, that is between the two adjacent atom. The angle between the two adjacent atom, it is called as the dihedral angle. So angle is 60 degree. So now the angle has increased, it means the strain has decreased. So in the staggered form, it means degree, that is, the angle is 60 degree, it means there is a less strain and high stability. Whereas in this, the angle is 0 degree, means the adjacent atom, two adjacent atom are very much close to each other, so the angle is 0 degree. So eclipse, it means they are having high, very much high strain and less stability, and the angle is 0 degree. That is, the two adjacent atoms are very much close to each other. Whereas in this, the angle is 60 degree. It means the angle, that is the two adjacent atoms, are far from each other and there is less strain and they are having high stability. That it is the same, it is the graph, that is the dihedral angle and the potential energy difference. Now, if you see the dihedral angle, if it is 60, if it is 60 degree, it means it is having less potential energy. That is, they are much stable. 60-degree angle means the two adjacent atoms are far from each other and they are stable and there is very much less strain and less energy. Less energy means less strain and high stability. Now, in this, it is also having, if the angle is 180 degree, now the hydrogen atom, they are far from each other and they are also stable. So if you go from, that is dihedral angle, that is 60 to 180, 180 is also stable. The hydrogen are very much far from each other and they are having less strain. They are less strain and less potential energy. It means high stability.